right? So I have the honor to finish this day. I think I'm the last talk. Either the honor or the burden, I'm not sure, because people are hungry and they want to eat, or they want to go out, get some fresh air. Um, until now, I'm still not sure what I actually want to say, because I had a plan of what I want to say, but I saw a couple of slides today and a couple of presentations today where I was thinking, aye, you need some researchers. Because I want to show you today with my presentation, hopefully, that researchers are not these nerds sitting in an office, grading exams and talking about numbers all the time. Research can be sexy, can be interesting, and you need it, that you should not otherwise waste some money. So my name is Stefan Flagner. I'm in the Department of Nutrition and Movement Science together with Hannah, you have seen her already, but also in the Department of Finance together with Niels, Pete, and also with Nico, who was before me. And I asked myself one question. What do we need in order to perform optimally indoors? We talked a lot about health today. Health is necessary, but I had the feeling, and before I did this PhD, I worked in Luxembourg in the financial industry, and if I would talk with my manager there about health, he would be like, yeah, but what does it cost me? If I talk about performance, it becomes a bit more sexy, because everybody wants to perform well. Everybody wants to understand, oh, you want to make my employees perform better, earn more money? That's a different talk than just you want to make them be healthy. Healthy is also important, and it's a need, but performance is a different thing. And more important is also to keep in mind that everybody was born healthy and was born with the optimal performance. It's nothing we are earning, it's something we are losing by the environment we are exposed to. Keep that in mind. We have to earn it back, but it's not something we never had before. So three key aspects. One aspect is light. Light is the most important factor to determine your inner clock. It gives your body the signal, this is the time of the day. And your body needs this signal in order to align all the processes regarding liver, regarding heart, regarding lungs, regarding brain, regarding gut. They are all aligned to what is the time of the day. How does that work? You have specific cells in your eyes. They're called melanopsin cells. They're right in the retina, so on the back of your eyes. And they are photosensitive receptors. So they react to the light intensity, but also to the color and to the position of the light. And they send a signal to your inner clock, which is the suprachiasmatic nucleus, which is a part of your brain. And this is basically the nucleus stems, or the bunch of neurons, which tells you this is the brain, this is the time of the day, and it gives a signal to the other part of the body. We had an interesting discussion today, or an interesting presentation today about certain lights indoors, right, and how that would be better for performance. I have not seen any artificial light which comes even close to substituting sunlight. And that's a sad assumption, that's a sad statement I have to make here, but honestly, the best light you get is going outside. We know that windows are blocking way too much photons to get this very strong signal to your brain. We know that the human body, the human biology, how it works, it needs to know that the sun is changing over time. That's what I mean with changing the position. This is never happening with the light here. We talk sometimes about color, that is fine enough, but we also never talk about the change there. So that's one aspect I haven't seen so far. I don't know any company who goes into this direction. So for now, my advice is go outside, because buildings still make you sick when it comes to regards of light exposure. So that's the first thing. Second thing is movement. We all know physical activity is important. We all know that, and there's great studies done about that, you have to understand that the evolutionary advantage of the human body is that we are the best long-distance runners on this planet. There are many animals who can run faster. There are many animals who can swim faster, but nobody can run as far as we. Our whole human body is made for running and moving all day long. The brain health, the health of your lungs, the health of your heart is related to that. So physical activity is important, but I don't talk about we put a gym in a building and they do it for one day and the rest of the day they are sitting. That's not how it works. You need to spread it over time. And during the presentations I saw today, I saw many pictures from Wageningen, from Maastricht, from Amsterdam. And what I saw in these pictures is chairs. I didn't saw any standing desk about that. But we are made, the skeletal muscles are made for standing, not for sitting. This is one thing. The second thing is, and I'm also sorry to say that, but physical activity will not solve the obesity pandemic. It will not. I was with also Hannah in Quebec City the last week in a conference about energy metabolism. So they are the leading experts when it comes to energy expenditure of human beings, so how many calories you burn. And basically the takeaway from that one is physical activity, yes, has an effect, but what you eat is way more important. It's way more important to lose weight and to have a weight management. You can see from studies, and we can go into the details after this, after my talk, that physical activity alone will not make you lose weight on a substantial and on a sustainable way. So this is something healthy buildings have to take into account, but still I want to promote physical activity. Last thing is air quality. We saw a lot of presentations about air quality. That is also interesting, and I agree in some regards that air quality has an effect on cognition, a negative effect on cognition. But I disagree at the part that it's carbon dioxide. Because you see many papers about carbon dioxide. Carbon dioxide is the new big thing. Carbon dioxide is really a problem. That's not necessarily the case. We actually don't know that. We use carbon dioxide as a proxy to estimate bad ventilation rates, but there are other stuff called volatile organic compounds. They could actually have this effect. It's not carbon dioxide itself. And how did we do that? So we did one study here, which you see in the picture on the left, where I put people into one of the chambers. I induced pure carbon dioxide, but still I had a high ventilation rate to really look at what is the effect of only carbon dioxide on human cognition and in human physiology. And what I found was nothing. Which shows already that the human body is quite adaptable. And that's what we talk about resilience, right? That because what I found is that the respiration is changing. The human is even unaware of what is the CO2 condition, can still adapt. So there is something in our brain which is outside of our modern awareness, but still the human body knows how to keep homeostasis. And sometimes we forget that. We have this plenty buzzwords, this is good, this is bad, but we really underestimate the adaptability of the human body. The second thing is, and this is what I'm going to do with Nico now, is we look at the classrooms and we look at these kids who are exposed to high CO2 conditions, or should I better say to bad ventilation rates, right? And we look if kids who are healthy in terms of low BMI, in terms of high physical activity, but also have a good nutrition, are actually more resilient to that. Coming back to resilience. Of course, we can talk about massive investments into buildings, but maybe we should talk about making ourselves, our human body, resilient. But for that, you need researchers, because we understand how the human biology works, and we understand how to translate that. But we need also you to translate that to practical implication. That was my talk. Thank you very much.
Are there any questions? Oh, a bit too fast. Yeah, this end of the day.
I have a question about homeostasis, because we've heard that while temperature is stable, high but stable, or CO2 is high but stable, it works. But what we see in schools, for example, and if you let a classroom in, then it spikes really high, really quickly to high levels. How does the off-balance of the homeostasis actually influence then?
What exactly do you mean is going high?
So when it goes from 400 to 2000 ppm, does the change influence the productivity of the children, or is it something else?
Well, again, and that's why research is sometimes a bit tricky. We don't know that necessarily. So first of all, at least from my lab study and from other lab studies, we see that CO2 itself is not the case. But the problem is we are not only breathing out CO2, there are certain these volatile organic compounds, which are other compounds the human body is emitting, but there are also compounds which are emitted by the carpet, by the painting, by the floor. And we now, or the research goes now to the direction to assume that these particles maybe have another effect on the human body, because CO2 is a gas, and the human body seems to be very good in keeping homeostasis in terms of keeping the CO2 level in the blood on a good level. But if you talk about fine particular matter, for example, it's a particle, it's not gas. So it has a different effect and it has a different distribution rate in the human body. So it's hard to compare that and come to like this clear solution.
Yeah, is it easy to get this homeostasis of balance?
I know what you mean. You want to answer it, Hannah? Please, go ahead.
Take the cube. Okay. All right. So in terms of temperature, of course, the body reacts to the delta, the change, because, for example, if the body senses a change in skin temperature that is quite fast, it will make you try to get out of that situation. Because we are all comfort seekers, and I haven't said that, usually I always say that in my presentations, because of evolution, because we need to protect our body from influences, we need to try to stay as comfortable as possible, because it will actually make us survive better. And we're still in this survival mode from our biology. Of course, we don't need to be there anymore necessarily, because we're very well protected, we have food, we don't have predators anymore running around chasing after us. But the system reacts to the change quite quickly. So an increase in temperature, probably also an increase in CO2, I could imagine. I'm not into that research so much, but that gets detected and gets picked up and makes you want to get out of that situation.
Yeah.
Yes.
Just to shortly answer that, so you have pH-sensitive receptors in your brain. These are neurons, and they fire higher if the pH level changes. pH level is changing if there is more CO2 in the blood. You get a panic attack if you breathe CO2 up to 10,000 ppm. You will never find that indoors. You will find 2,000 or 3,000. That's one of the problems. We know CO2 has an effect on very, very high level. But on the levels we talk here about, it's not so clear.
I wouldn't say that you never find that. Actually, it could be found.
That's what I talk about research. You say something, somebody says no.
Never say never.
Okay. Yeah. Give a round of applause. Excellent research.